Okay, I want to make another little short video for you today if you are getting stuck on converting between moles and molecules. So I've had a couple of questions about that, and it works the same way as converting from grams to moles and moles to grams, only the conversion factor is different. So the relationship between moles and molecules is Avogadro's number, right? 1 mole of anything has Avogadro's number of particles in it. So 6.02 times 10 to the 23rd particles. And those particles can be molecules if it has a formula, so like water. Or it could be atoms if it's just an element, or it could be ions, or like our mole song video we watched. It could be marshmallows, it could be pennies, it could be whatever. All right, so let's work on, and let me show you how I enter this into the calculator, and that way your exponents will be correct and you won't lose track of what you're doing when you put this in. So if we have 3 moles of carbon atoms, how many atoms is that? And so we're going to start with our given 3 moles of carbon. We're going to multiply by the conversion factor, which is just that relationship, 1 mole of anything. So 1 mole of carbon atoms, 6.02 times 10 to the 23rd atoms. And you guys, I know like this one is a little bit obvious, right? If 1 mole has 6.02 times 10 to the 23rd, 3 moles would just have 3 times that. But I want you to get into the habit of showing your work so that you can show yourself that the units cancel out. Makes your life much easier if you can show the math, if you can show that moles divided by moles cancels out and you're only left with the unit that you're looking for. All right, so some of y'all have no problem with this, but things go a little sideways when you put it into your calculator. So let's take a look. So 3 is my 3 moles multiplied by Avogadro's number. And so this is where I think you need some help. 6.02. That exponent button, if you hit the second and comma, it's the little EE, the yellow EE. When you hit that, it shows up on your screen as just a capital E, and that takes the place of times 10 to the third. Times 10 raised to a power. Sorry. So when you use that button, you don't have to use times or 10 or your raising to the next exponent button. It takes the place of all of that. So 6.02 times 10 to the 23rd, and you're going to get, well, 3 times 6 is 18. So you would get 18 times 10 to the 23rd, which is the same as 1.8 times 10 to the 24th. So 1.806 times 10 to the 24th atoms. If we looked at this, we only know one significant figure in our original number. We really should round this off to just one significant figure in our answer. And that'd be all the way to 2. 2 times 10 to the 24th atoms. I know those are not equivalent, right? But our rules for significant figures, if we only know this number that we're starting with to one significant figure, then all of these other numbers that your calculator gives you, they don't have a meaning in the real world. They are not significant. So we can practice using our rules for significant figures as well. If you write this, it is not going to be wrong, right? But this one is a better answer because we truly don't know it any more accurately than that. Okay, so pretty easy starting with moles. What if we start from atoms? What if I have 7.4 times 10 to the 24th atoms of gold? How many moles is that? Ooh, my writing is messy. So sorry about that. All right, so same process. This time we started with atoms, so our atoms have to be on the bottom. 6.02 times 10 to the 23rd atoms. in 1 mole of gold. Let me get this out of the way. And how are you going to enter that into the calculator? Hopefully you're practicing with me, or you can pause it right here and see if you get the answer that I'm going to get. 7.4 times 10 to the 24th. So second comma to give me the exponent. 24th divided by 6.02 times 10 to the 23rd. Look how that looks on the screen. I don't have any times or 10 or raised to any power. I don't have any parentheses. If you do not use this exponent button, then you better use parentheses. All right, so this gives me 12.29 moles of gold. And let's look at our units here. Atoms of gold on top, atoms of gold on bottom, and we did 7.4 times 10 to the 24th times 1. We didn't show the times 1 divided by Avogadro's number. This is our conversion factor. 1 mole has 6.02 times 10 to the 23rd pieces. I can use that this way or this way, depending on what I'm starting with. Pay attention to your units, label everything, and you should get the right answer. Hope this makes sense and doesn't confuse you. Have a great day. Hope y'all are doing great. Keep sending me questions, comments, feedback.